Before we move on to more Python stuff, I wanted to first mention a few things which are more like soft skills of programming, which I thought were important to mention. So first I want to say a few words about debugging, which since all of you have programming experience from before this course, I suppose it's not unfamiliar to you, the concept of debugging and how to do it. I suppose all of you know that we can use prints as a quite convenient trick to debug things. And so actually this is this is a quite, I think, very conventional thing to do, and it works, even though there are more fancy methods we can use. So for example, suppose we want to debug this short code. We have some function with 2 arguments, and for some reason it doesn't give us back. You cannot hear? Maybe you can move closer because it's hard for me to. I think it's only also, other people cannot hear me?
Sometimes there are missing words because of louder and...
OK, I will try a little bit, but it's difficult for me to really shout. OK. So yeah, so suppose we have this function with 2 arguments, and it doesn't give us back the kind of output that we expected. So a quite convenient way to debug it would be just every time we run a line, we can print whatever the current value of these variables. And this is quite straightforward. I mean, we can just do it, and we can track what we get to the screen. And as soon as we detect something that we did not expect, that's probably where the problem lies. So you can just add as many prints as you want. Just one thing is, don't forget to later delete them. Sometimes we get your submissions of homework, and we see some debugging prints. So we will actually deduct points for that. Please make sure that you submit clean code. And also when you work for yourself, make sure that you clean the code after you finish debugging. A nice trick you can use to remember to clean everything is there is some convention to use the XXX sign, which means delete me. So you can put for every print or any other line of code for debugging, you can put this comment afterwards. And then it's very easy to detect. It really is salient. And you can also use Control-F to find it. Another useful convention is the to-do, which pretty straightforwardly means to do something. Also, people use quite often. So again, because you use Jupyter, I think pretty much the only way you will have to debug your code is through prints. Because actually, as code editor, Jupyter is quite basic. It doesn't provide you with too many features. But if you sometimes happen to use a more sophisticated IDE, for most of them you also have debuggers, which are these more fancy tools which allow you to run the code in debug mode and then to put some breakpoints maybe, like you can see here. And then you can inspect all your variable values and stuff like that. But again, because we use Jupyter in this course, that option will not be available to you. So it's just something that takes practice to learn how to debug your code effectively. Now, another soft skill which I wanted to mention was, we call it the learning how to learn. Again, because I said it already in previous lesson, because it's impossible to really teach you to do everything you might want to do in the future. And there is no way to avoid it. You will encounter problems sooner or later. You will have to learn how to find answers to your questions. So it could be how to do something which you don't know how to do in Python or in some package you use, or how to do something properly. Maybe you can do it, but you have a feeling that it's not a very elegant way, and you think there should be a simpler way, a better way to do it. Or even something doesn't work for you. You think it should work, but it doesn't behave as you expect, and you have some bug which you cannot really wrap your head about. So, for all of those reasons, you might want to look for answers. So here is a short list of some options you have for getting answers. So first, of course, Google is like, I think, the most convenient place to start. This will solve your problem 99% of the time. And Google might give you some results for some specific quite common web pages. For example, it could direct you to Stack Overflow, which is a very nice website where people ask questions about programming and other people answer them. So if you get there, you know that you're in a good place. You could reach to the Python docs, which is the official documentation of Python, which is also a very trustworthy resource to look for. And sometimes if you use some library or some piece of code, maybe there is a manual which you could read and find some answers. In very rare cases, sometimes you don't have very good documentation if you use, for example, some rare library. But many times it's open source, especially in Python. So even if sometimes you actually look at the code of the people writing this package, you can find there the answers you're looking for. Of course, this is not the preferred way. Another convention, sometimes people use what's called a README TXT file. That's like a convention for some text file with some explanations or documentation which you can look for. There are also tutorials, forums, GitHub issues, which I will show in a minute. And of course, you can also just play around. You can, for example, open the Python shell, which I showed you earlier, and just try to run and try different things, and it might work for you. Lastly, if nothing works, you can also ask for help. So there are many forums that you can reach to. There is the Stack Overflow, of course. So if you find someone already asking that question, of course, it's better. But if you see that nobody seemed to ask that question, you can just look at it for yourself and ask yourself, and maybe someone will help you, hopefully. And of course, in the environment of this course, you can also ask other people. You can ask in the Moodle. You can ask us. But again, you have many options. But it's really better if you first try a little bit yourself. I think it's really an important skill to practice. So here you can see, for example, a print screen from the Stack Overflow website, which is, again, very, very simple. You just you have the title of the person asking the question, and then you have the content of the question themselves. And you also have this rating, which is very nice. You can see how many people rated this question. And if it's very highly rated, then it's probably a better place to look for. And then you have the answers, which are, again, sorted by the kind of rating they got from other users voting for them. So in this example, I just searched for how to create a range in reversed order. And you see the title pretty much hints that this is indeed the question that was asked. And then the top-rated answer, you can see it already gives you the snippet of the code that does it for you. So once you get used to it and you do it a lot of times, you don't actually have to read everything. You don't even have to read the content of the question or even what people answer. You can just look at the title, look at the rating, see it's trustworthy. And then like 90% of the time, you'll see that the first code snippet will just give you the answer. So it's very quick to see and just to try, and very easy to find answers this way. Here I put you with a print screen from the Google documentation for a specific class called String.io. And again, this is a very friendly kind of resource. So it gives you all the details. It gives you a lot of code examples. So if you reach this official Python documentation, you know you have reached a good place. This is from GitHub, where people most of the time will put an open source version of their code. And within the GitHub, you can look at the code itself, or you can go to some issues. Sometimes if you Google search maybe a bug or some question about a library, it will give you directly a link to one of these issues with someone already pointing out this problem or question that they have. And it's like a forum thread. You can scroll through it, and you can see what people say about it. And many times it will give you an idea. Another thing which is more specific to bioinformatics is the BioStars forum. Which again, if you Google something, sometimes it will point you here. This is very much like Stack Overflow, but more specifically to biology and bioinformatics stuff. So if you look for something related to some biology library, good chance you will get here. Okay, and that's it about these soft skills I wanted to mention. Any questions? Okay. So let's move on to today's Python topics. And we begin with functions. So again, all of you should know what functions, sometimes called methods or procedures in other languages. But why do we actually want to use functions? Like, what is the motivation? So I think there are two main motivations to write your own functions in your code. The first is what is called reusability, which stems from the fact that code duplication is a bad idea. So suppose you have some algorithm or some functionality or some piece of code that does something, and you want to do that thing in multiple different places in your code. So actually you don't need functions for that. You can just copy paste and put the exact same code in some other place in your code. But this is probably a bad idea for several reasons. First, it will make your code much longer than it should be, which will make it harder to read and to maintain. And even more severely, it will be difficult to maintain because suppose you then want to change something. You found maybe a bug in your piece of code, and you fix it. If you duplicated it like 10 times, you would then have to go through all the 10 instances of this code in your analysis and fix all of them. And if you have forgotten one of these instances, then but for you, the bug will remain. Whereas if you use functions, you need to maintain it just in one place, and you need to fix all the bugs just in one place. So it's much more, it's much safer way to work. And much more elegant and easy. The second reason, which is even more subtle, is the issue of readability. So even if there is some code which you know for a fact that you are not going to use it more than once, there is just one place you need and want to use this piece of code, very often it will still be a good idea to make it a function rather than just put it in line with the rest of your code. And that is that once you create functions, it creates this kind of logical separation between different components in your code. And then it's much easier to read it and again to maintain it, where you know that at each given time when you look at the code, you just need to keep in mind just this context of one function, which is 6 lines long, instead of this huge chunk of code, which could be 200 lines of code. So it's really a huge cognitive burden to navigate through this mass of 200 lines of code where you need to keep track of all the different variables which you define, which are relevant, which are not relevant. And it's really, really difficult to do that. Whereas if you create these short functions, which are only a few lines of code each, it's much easier to navigate because each function you know exactly what is the input, what is the output, what are the variables that you need to remember. And everything becomes much more separated, and dividing it into components make it much easier to follow. Okay, so let's see some code examples. So we'll begin with functions and also cover some other topics. No. Okay. So I opened the notebook, which I put in the Moodle. Can everybody see? Now? More? Now? Okay. Okay, so here you have the basic syntax of defining a function. So we simply use the def statement, def, followed by the name of the function, followed by parentheses, which are empty in this case, followed by a colon because we open a new block, And then the new block, which would be with indentation, like everything, which opens a new block in Python. And then just the body of the function, what it does. So in this case, we just define a very simple function that uses the random choice function to select one random nucleotide and to print it. And then we just use it. We iterate 5 times, and each time we call the function again. And then what we get is just 5 random nucleotides. Of course, we can have our functions with some arguments, and we can return some value. So in this case, we have just one argument called a, which is expected to be some number. And we simply return the square of this number. And now when we invoke f with some input with 5.5, then 5.5 will become the value that is assigned to the variable a, the argument. And then the output of f, we can assign it to some new variable. We call it b, and we print b, and we get the square of 5.5. And of course, we can have more than one argument. So here we take 2 numbers, and we calculate some weighted average of them, and we print the outputs. Now, a nice thing that Python allows you to do is to provide the argument values not only by position, which is what I did up until now. So here, the first argument went to arg1, and the second went to arg2. We can also do it by what is called by keyword assignment. Okay, so the first argument, arg1, was provided by position. So we know that the first argument is arg1. So in this case, it will be 1. But then the second argument we provided by keyword. Okay, so we specifically state the name of the argument. We use the equal sign, and then the value we want to assign to it. And so we get the output with 1 and 2. Or we can even give the 2 arguments with this kind of keyword assignment. And also note that in the second case, we actually give it in reversed order, but it doesn't matter, because what matters in the keyword assignment is the name of the variable. So actually here, the first one we give the second argument, and the second one we give is the first argument. But the rule in Python states that if we want to provide some mixture of positional and keyword arguments, then the positional ones need to come first, and only then we are allowed to provide keyword arguments. Okay? So, and the reason is that otherwise it would be just confusing. So here we give, is it the first argument, the second argument? It's not clear, because we also had some keyword arguments first. Okay, so just to make it clear and not confusing, Python just forbids it completely.
Can you explain that again?
Yeah, so this threw an error at me, because I first provided the keyword argument, the arg1, and then I tried to provide a positional argument, okay? So now this third thing, what is it? Is it the first positional argument? Is it arg1? Is it arg2? It's not clear what it is, okay? I mean, for the
Why is it not just arg2?
because it's supposedly the first positional argument that I give, right? I mean, keyword arguments are entire species completely. So you can also just think about it as just see it as a rule that the people who developed Python decided that you just cannot do it, okay? They just don't allow you to provide positional arguments after keyword arguments. Yeah?
So what is the difference between this one and the one that you changed, like 1 and arg2?
This one?
Yeah, what is the difference?
So here I first gave the positional arguments, okay? So 1, and then the keyword arguments, okay? This is allowed. This I can do, because now it's very clear what is this argument. It's very clear. It's the first argument, okay? And the keywords, there is no ambiguity about them, because they're provided by name. So I explicitly state their names. Whereas here, if Python allowed me to put positional arguments after keyword arguments, it would create this ambiguity that they didn't want to introduce into the language. So they just said that it's not allowed. Okay? Okay, so using this feature of keyword assignment also allows me to specify default values for functions. So here I created a function with 2 arguments. The first is just a regular argument. The second one, I created it what is called a default value by using this, again, equal sign and some value. What I basically say that the duplicate function can get these 2 arguments like any other function, or it can just get the first argument. And if someone invokes the function just providing the first argument, then that person doesn't need to provide the second argument, because by default it will take the value 2. And only if the user explicitly states a different value, only then will it override this default value, and then we'll get something else. So here you have some examples invoking this function. So in the first instance, I just give it 1 argument, which goes to the string argument. And the number argument just keeps its default value, which is 2. So what I get is twice foo. Similarly, I could just give it the number 2 again. It wouldn't change anything because I just provided again the default value. Okay, so now 2 goes to number, which is the default value anyway, so it doesn't change anything. I can also provide it by keyword assignment. Again, doesn't change anything. Or I can override it. Again, I can override it with a positional argument or with a keyword argument, and then it actually changes. Now number becomes 5 instead of 2, and I get foo 5 times. Yeah.
Do that for any data type? Like, could you do that for lists?
Yeah. Yeah, anything. Okay, and again, with default value, we again have the same rule that arguments with default values need to go to the end. I cannot have some argument without a default value, then an argument with a default value, and then again an argument without a default value. Okay, for the same reasons, because it would create ambiguity if Python allowed it, so they don't allow you to do it. Okay, another thing that is worth noting, that unlike other languages, which sometimes return a value and sometimes don't return a value, in Python actually all functions return a value, whether you explicitly state it or not. So let's look at this example. We get 2 numbers in this function, and only the first is bigger than the second, we return the difference between them. So when we call it with 5 and 3, of course, this condition is met, and we get the difference, which is 2. But in the second example, this condition is not met, and we don't explicitly return anything. But again, the rule in Python is that if you don't explicitly return something, then none is just returned as the default return value. Okay. Now it's considered not it's unconventional to do it. So if you write a function, make sure that it either returns something or doesn't return. And if in some instances you just want to get a none, then it's better to do it explicitly. Like you can write here something like else return none. Now in some sense this is redundant because it doesn't change anything, but I think it makes the function more easily read, so people actually understand what you try to do. Whereas if in some conditions you don't return anything, it's just confusing to the reader of the function. Okay? Okay, so like you heard in the bonus presentation today, like virtually everything else, functions are also objects. So like any other objects, you can assign them to new variables. So I can do something like f equals calc. And then f becomes yet another reference to the same function, which you can also invoke in the same way. And when you ask what is the type of f, you get that it's type function. And like any other variables, you can move them around. So you asked earlier whether we can give also other types to function, whether we can give list arguments or set or dictionaries. And the answer is, of course, yes. And we can even give functions as arguments to functions. So this is sometimes confusing. But yeah, we can do it, and it's useful in many cases to provide a function as an argument to another function. So let's see an example of that. So let's begin with the second and third functions here. So let's say we created two functions, one that converts a single nucleotide from an RNA to, from a DNA to an RNA nucleotide. So if it's a T, it's expressed to you, and otherwise it remains the same. And likewise, we create a function that converts one RNA nucleotide into a DNA nucleotide, okay? But these two functions work just for a single nucleotide. Now suppose we wanted to use these functions to convert a whole sequence from DNA to RNA or from RNA to DNA. Actually, we don't have to write two separate functions to do that. We can write just one master function, which will be generic enough to do both. And the way it works is this master function, which we call convertSeq, it gets a sequence argument, and it also converts a function. It gets a function that converts a single nucleotide. And now it uses this function to work element-wise on each of the nucleotides in the sequence, converts them using this function, and then return the output. Okay, so we initialize an empty list of letters. And then for each letter in the seq, we append to this list whatever is the output of this convert single letter function over this letter. And then in the end, we use the join function to concatenate everything together and get the output. And now we can use this master function with some DNA sequence, giving it the DNA to RNA function, or you can provide it some RNA function, giving it the RNA to DNA nucleotide, and it works. Okay, using this trick of providing a function as an argument to another function. Okay? We can even define functions within other functions, which again, it's not very common we want to do it, but sometimes it is useful. So we can have this DNA to RNA function that works on a whole sequence. And within this function, we create some helper function that will help us to achieve it, which converts just a single nucleotide. And then we use it in the context of the outer function. And then what happens is this inner function is only accessible within the context of the outer function. Okay, and we can just use it within this context. We won't be able to use it anywhere else. But this is by design. This is what we want. This is just a helper function that helps the outer function achieves whatever it tries to achieve. Another subtlety which is important to pay attention to when we work with a function is the issue of global versus local variables. Okay, so suppose we have this function. Okay, so what we do here is we initialize this variable which we call x, and we assign it a value of 5. And then we define some function which assigns x actually the value of 3 and returns x plus 1. Okay, so when we call f, we expect to get 4 because this is 3 plus 1. But then what happens if we ask what is the value of x? What do you think? What will be the value? 5. Why 5?
There's two environments. One is that includes sort of same as the definition. The second definition of the function is inside the function.
Exactly.
Inside the global of the environment, one inside the environment of the function.
Right. Yeah. Exactly. So what happens is it's again it's quite confusing. We have this x variable and here an x variable, and although these two are called x, these are actually different variables. This is not the same variable. Okay. This is a global variable x, whereas this is the local variable x. They have the same name, but if you check their ID, like you saw today, you'll see that they actually point to completely different objects. They are not the same. They're not the same variable. Okay. So here, when we assign 3 to the value of x, we actually create a new local variable, which exists throughout the context of this function every time we invoke it. But it doesn't do anything to the global variable x, which is a different variable. Okay, so like you said, we will get 5 and not 3 the second time we print x. And sometimes this will even create an error for you. So for example, if we create these two variables, 5 and 6, and then we want f to increase the first variable by the value of the second value, you expect this to work. You expect now var1 to be 11. But actually, this will raise an error, and you will see that it says a local variable var1 referenced before assignment. This is confusing. It says, I don't know what var1 is, but there is no such variable. And you may be puzzled by it because you said, no, I defined a variable 1, but that's not actually what you did, because this is a global variable 1, and within the context of the function, it expects to find a local variable. So it thinks it doesn't know what var1 is, and this can be sometimes quite confusing.
So how do you solve it? You just say within the function again var1, var2 equals.
Yeah, you can do it. Like if you want, if you just need it within the context of the function, you can just pass it inside, and this will work. This will do absolutely nothing, because f just changes some local variables, which then that doesn't do anything with them, doesn't return anything. So this kind of function is quite useless. But you can do it. This will work. But what happens if you, that's actually what we want to do. We want some function to actually change some global variables. I mean, it's considered a bad practice to do that. I strongly recommend against it, because this is sometimes called functions which are obsessed with global variables, and this is not a very good design pattern to write code. We want the functions to be as much self-contained as possible. This will make it much easier to read, to understand, and to debug. Like I said earlier, the whole reason we use functions is because we want to compartmentalize our code into different components. And if they are interdependent with some global variables, this breaks this logic. We don't want them to be coupled with what we have. But in some rare instances, we do want to do that. And there is a way to do that. We just use the global statement. So if we begin a function with a global statement saying, OK, we want variable 1 and variable 2 not to be local variables. We want them to be references to the global variables. Then it works. Then you can actually do it. And now Python knows that these are global variables, and it actually changes the global values. And it does what you expect it to do. OK, any more questions about that? OK. And again, sometimes it will be even more confusing. For example, here, again, we have this function f1, which takes some global variables and appends something to it. And you might expect that it won't allow you to do it, because you will need the global statement to say that x is a global statement. But actually, this will work, at least the first time. So when you use f1, you can see that afterwards, when you print x again, it actually does what you expect it to do. Whereas in the second case, instead of the append, we use the other option, which you might think is equivalent. We use the plus equals operator, which would update the value of x and add a 6 to it. But now, all of a sudden, it doesn't work. Now, again, it says it's referenced before assignment. So it appears that in the second case, we do need to state the global. And if we do that, then actually it works. And now the reason it doesn't work the same is because the append function doesn't actually replace the variable. It just modifies it. It takes the existing list, just puts something in it, and it remains the same list object with the same identity, with the same ID that it was before. Whereas the plus equals operator, it doesn't modify the list. It creates a new list and then reassigns the new list into the same variable. So now you actually need to state that it's a global variable. So in the first, you don't need to state that it's a global, but I recommend you to still state that it's a global. So it will be much easier for you and other people to understand and to read this function if you make it clear that in this case, you want x to be global. And this will also flag it for you that maybe you have some bad design here, because again, you have this function obsessed with some global variable. OK, so I would recommend you not to count on this behavior or that behavior. Just whenever you use a global variable, just explicitly state it. And it's always better. Any questions about functions, defining them? Yeah.
But if I said that, for example, if I take the f1 and I put the x inside the parentheses, it would also take the x, the global one, right?
No, if I put it in parentheses, then this will actually become a local variable, because the arguments are always local, OK? Now I'll just get an error because I don't really provide x. So yeah, it's a missing argument error. But if I call f1 with x, this will do the same thing. Okay, any more questions? Okay, finally I wanted to show you some built-in functions, which are just built-in into Python, and you can just use whenever you want. So some useful arithmetic functions include the sum function, which you give it some collection of numbers, and it will sum it over for you. It will give you the summation of this. So if we sum all the numbers between 0 and 4, we will get 10. We have the maximum function, which again gets some collection of numbers and will give you the maximum number, or minimum, which will give you the minimum number. Now, you can also note that I used them somewhat differently in these two instances. So in the first one, I gave it actually a list of numbers, whereas in the second one, I just gave it some 4 different arguments. And this is a nice feature of both of these functions, is that they work both ways. So you can either give it a single collection, a list, a set, or any other thing which contains some elements. Or you can just give it the elements directly as a number of arguments, and it will work the same way as you expect. We have the absolute value function, which you give it some number, and it will calculate the absolute value of that number. Another quite useful function is the dir function. This is not actually useful for the code itself you want to write, but it's useful sometimes for playing around with some piece of code or some library or something that you don't know how to use. So if you call dir on some object, this will automatically give you all the attributes which are associated with this object type. So in the case of a string, we will get all of the functions and attributes which work with the function. For example, we get the isLower, which is indeed something we can do. We can calculate s.isLower, which says whether or not it's lowercase, and in this case it's true. Okay, so this basically just gives you everything you can do with this kind of object, which you might not know. In Jupyter, you have a more convenient way to do. You can just use s dot and then use the tab, and it will give you all the options of all the things you might want to do. So it's even nicer than to use this dir function. And if you call dir without any arguments, it will just give you everything that is currently in the global scope of this in this environment. So in this case, just all the variables which I defined up until this point. You can see everything which I defined earlier. Everything is just given as the names of them as a strings. I can also dir what is called the underscore underscore built-in underscore underscore, which is just some artificial module that Python creates with all the built-in types and functions. So everything that is built into the environment of Python, you can see here. For example, the dir function itself, did, int, all the kind of functions and types which you can use by default, you can see here. And this dir function, it's actually a function that actually gives you some output. What it gives you is a list of strings with the names of everything that is defined. So for example, if I call dir with the built-in, I actually get a list of strings with all the names of the types and functions that are built into Python. So I can actually iterate over them, and each one put into a string called s, and then I can do some condition. For example, see if set is part of the string, and if yes, I can print it, and I can just work with it like I work with anything else in Python. If I found some function and I want to see what it actually does, there is yet another built-in function, which is called the help function, which once I give it some function or some type, will just give me the help, some simple manual of how to use it. But again, with IPython and Jupyter, I have an even more convenient way to do that. I can use the question mark. And if I execute that, I will actually get a new window in Jupyter that gives me the same kind of documentation. And I can then close it. And I can also check for some function which is bound to this type. So for example, I know that the string type has a function which is called the lower, and I want to see what it does. I can just write str.lower question mark, and it will give me the documentation of what the lower function of strings does. So it says that it returns a copy of the string converted to lowercase. So if I take some string, abc.lower, it will give me a lowercase version of the string, okay? Final questions? Okay, so I think we'll stop here.